Hi there, it's December 6th, 2015. I was just looking at this in telecast map at the earthquakes. The weird thing about this is you can see these earthquakes here, but then it stops and it won't let me see this over on this side unless I move it over this way, and then you can see that there's been a lot. And of course, if you carry the map down to the other side, it's like quite a few along the same track. See, these come up along here. So then, out of curiosity, I thought that I would look at these clouds here. That looks really weird. Sorry, just a comment. So then I'll show you kind of how my brain works. The next thing I decided to look at was this, the morphed integrated microwave imagery, total precipitable water on the global scale. I find this quite interesting. Right up here is the timestamp as it's moving. And then I saw over here in Australia, I thought this looked kind of cute, this little crescent roll here that's winding up. But there's a strange little flash down here. It happens, you'll see it in just a minute. See that flash? Let me back my thing up a minute again. Right there. So I decided to look at the Australian part of this map, and it doesn't show up at all on here, but what shows up is this other thing right in here. Right there. And now if you remember, the earthquakes have been happening right around this area. So we have that weird little flash that isn't showing up closer to Antarctica, and we have this like half moon kind of thing right in there. Alright. So from there I looked at, if you go down to the bottom of here, you can click on these and then you can see still images. So I saved a couple of them so we can take a look. Hold on. Okay, now on here, this is the timestamp up here. Okay, well I forgot that I'm on a different computer, so I can't make this larger right now, but if you look, you can see right there that loop. Alright, let's close this. Okay, let's close this one. And let's go to the next one. Here you can see the loop again. Okay. Or the half moon. Okay, now maybe I should look at my documents, because I know I saved more than that. Okay, and this is the start of that weird light that was showing down here closer to Antarctica. And it's possible that energy is coming from Antarctica. And then here's the second little piece of it, and that's the only stills they have of those. Okay, I'm just going back to the Intellicast map here so you can see these earthquakes here, and the red is the latest one. And then it goes to orange, and then yellow, and then gray. And then we'll go over here on this side, and you can see this whole row. Now remember, we saw the weird thing in here, and then we also saw something down here, which that is a really strange cloud formation. And look at these earthquakes up here around Yellowstone too. That's interesting. Okay, let me go into, since we were looking at what is precipitated precipitable water in the atmosphere. This tells about what it is and how they're using a microwave radiometer to measure, which was in that moving picture that we saw. Um, it's the total columnar water vapor values, also referred to as the total precipitable water. The product is updated monthly, blah, 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 blah. What is water vapor? Over 99% of the atmospheric moisture is in the form of water vapor, and this vapor is the principal source of atmospheric energy that drives the development of weather systems on short time scales and influences the climate on longer time scales. Water vapor is a critical component of Earth's climate systems. It is the Earth's primary greenhouse gas, trapping more heat than carbon dioxide, which carbon dioxide is only one of the other gases in the atmosphere. Movement of water vapor and its associated latent heat of vaporization is also responsible for about 50% of the transport of heat from the tropics to the poles. The movement of water vapor is also important for determining the amount of precipitation in a region receives. Total column water vapor is a measure of total gaseous water contained in a vertical column of atmosphere. It is quite different from the more familiar relative humidity, which is the amount of water vapor in air relative to the amount of water vapor the air is capable of holding, which depends on the temperature of the air. In comparison, atmospheric water vapor is the absolute amount of water dissolved in air. When measured in linear units, millimeters, it is the height or depth the water would occupy if the vapor were condensed into liquid and spread evenly across the column. And here's the calculation for that. And then they measure it with microwave energy. And this is an interesting thing that kind of bothers me because microwave, as we know, cooks food, correct? So who are these people? The Remote Sensing Systems is a scientific research company located in Northern California, specializing in satellite microwave remote sensing of the Earth. Established in 1974 by Frank Wentz, Remote Sensing Systems, blah, 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 presently consists of a team of atmospheric, oceanic, and Earth scientists and support personnel. Okay, now this company is saying, oh, I thought there were some pictures below. Hold on. Here's where the pictures are. CRISP, which stands for the Center for Remote Imaging, Sensing, and Processing. Okay, so there's satellite in the above the atmosphere, sends down a signal, which that doesn't look like a very happy signal. I wouldn't like that right above my house. And here we're talking about another type of this is what they want you to get. We perceive the surrounding world through our five senses. Some senses, touch and taste, require contact of our sensing organs with the objects. However, we acquire much information about our surroundings through the senses of sight and hearing, which do not require close contact between the sensing organs and the external objects. In another word, we are performing remote sensing all the time. So they're saying it's no big deal because we do it when we look at something. Of course, I don't believe that we have microwaves come out of our eyes when we're looking at something. So anyway, then they're saying that generally remote sensing refers to the activities of recording, observing, perceiving objects or events far away. Blah, 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 blah. The electromagnetic, right here I am, radiation is normally used as an information carrier in remote sensing. So what they do is they send a signal out and it picks up information, and then when it is returned back to the picker-upper, it's got the information on it. And this tells you a lot of stuff right in here. And here's some of the things that they can use. And they're sort of saying that it's not any different than the sun. Okay, it comes from the satellite, bounces up, sun energy. This. Okay, I'll just read it instead of blabbing. In optical remote sensing, optical sensors detect solar radiation reflected or scattered from the Earth, forming images resembling photographs taken by a camera high up in space. The wavelength region usually extends from the visible and near infrared. So everything is emitting energy and it's being picked up by the satellite. Different materials such as water, soil, vegetation, buildings, and roads reflect visible and infrared light in different ways. They have different colors and brightness when seen under the sun. The interpretation of optical images require the knowledge of the spectral reflectance signatures of various materials, natural or man-made, covering the surface of the Earth. There are also infrared sensors measuring the thermal infrared radiation emitted from the Earth. Okay, so oh, sorry. So here we get down to some of the gravy. Microwave remote sensing. There are some remote sensing satellites which carry passive or active microwave sensors. The active sensors emit pulses of microwave radiation to illuminate the areas to be imaged. So now it's not the sun, it's coming from the satellite, okay? That's different. So there's additional radiation coming from the satellite, bouncing off of everything to pick up the image. The active sensors emit pulses of microwave radiation to illuminate some areas to be imaged. Oh, I just said that. Images of the Earth's surface are formed by measuring the microwave energy scattered by the ground or sea back to the sensors. These satellites carry their own flashlight, emitting, I love that term, flashlight, emitting microwaves to illuminate their targets. The images can thus be acquired day and night. Microwaves have an additional advantage as they can penetrate clouds. Images can be acquired even when there are clouds covering the Earth's surface. Now, this is a big deal to me. A microwave imaging system which can produce high resolution of the image of the Earth is a synthetic aperture radar, SAR. The intensity in a SAR depends on the amount of microwave backscattered by the target and received by the SAR antenna. Since the physical mechanisms responsible for this backscatter is different from microwave compared to visible infrared radiation, the interpretation of SAR images requires the knowledge of how microwaves interact with the targets. It requires that knowledge from scientists to be able to read the computer image that is generated. So there's more stuff here that you should probably read if you're interested at all. And then this is just a little piece that you might find interesting also. How does NASA communicate with spacecraft? Okay, so we're sending a signal down, and then how is extra data sent in the radio signal? In addition to sending information such as AM or FM waves, NASA scientists have found a way to make the same waves do double duty and send twice as much information at once by modulating them. And then here they tell you how they modulate it and that they send information into the subcarrier, which is referred to as the modulation index. And then there's a whole bunch of different things you can click on here and find out more information if you want. All the links are below. So here's a quick little thing that you should know. Harmful effects of electromagnetic radiation. A lot of people will try to convince you that the negative effects of electromagnetic radiation are simply a hoax or fairy tale. But what they're saying is research is overwhelmingly proving that this is not the case at all. Link below. Please feel free to read it. Thank you.